Okay, thanks a lot, everyone, for coming along to tonight's session. Just in case anyone's wondering why I'm wearing a microphone, it's because we put these things up on YouTube afterwards, so we try and live stream them. This month I was a little bit tardy in getting the live streaming address up, but it's up on the Meetup site. You've obviously got pizza and beer, so you figured that part of the evening out already. A little bit of useful information coming up next. Then I'll do a what's new in Azure since we last got together back in March. And this evening we have Stephane Budo from Vigilant IT, who's here to talk to us about Azure Site Recovery and VMware. It's actually a very interesting space in the Azure landscape, particularly if you're looking to do migration of workloads from either an on-prem environment or I think eventually also from other cloud providers as well. I think they're talking about, or they already have AWS support in there as well. So a very interesting technology and one that solves traditionally what's been a bit of a hard problem to deal with, that of DR and failover and being able to orchestrate that. But I won't steal Stephane's thunder. So I keep talking at the start of these sessions about survey that we put out earlier in the year. It's still open if you're interested in going and providing feedback into it. Part of the takeaway from that survey was would like some information about where we can find things, how we can see sessions that we've missed. So part of the reason we do the recording for these is so that you can go back later and watch them. This one hopefully will be the second one where we'll be end-to-end with no audio or technical issues of any variety. Fingers crossed, hopefully haven't jinxed anything for later. So videos are up on our YouTube channel if you want to go and watch them up there. And the slides, typically the slides that I talk to go up on the Meetup site as a PDF after the session. The slides from guys like Stephane will really be dependent on what they talk to at the end of the day. All the guys that come along and talk are always happy to take questions afterwards, or you can reach out to them after the session is completed. I'm happy if you want to drop me an email and I can get you in contact with Stephane afterwards as well if you've got any questions that you don't get answered this evening. So please go along and have a look at the slides and the videos if you want. Upcoming events in the Microsoft space. So last weekend we just had the Azure Bootcamp out at North Ryde. It was well attended. It was about 40 people came along to that. So that was a global event that ran across a bunch of locations around the world. After Anzac Day long weekend, which is this coming weekend, so next week on Thursday and Friday, there's the Microsoft Cloud Roadshow, which is here in Sydney. That's a free 2-day event. I don't know what the status is of registrations for that at the moment, whether they're full or not, but if you've got some space in your calendar and there's still spaces, certainly highly recommend going along to that. They seem to have quite a lot of good speakers coming out from the product group in Redmond to talk at that event, so worthwhile getting along to that if you've got some time. What I'm going to do now is going to talk about a couple of groups of Azure technologies. So we talk about stuff that's in preview, so that's things that Microsoft have released that you can go along and try in Azure but don't necessarily have a service level agreement behind them. Talk about generally available items, which are things that have a backed service level agreement and that you can use for production use, and then talk about announcements. Microsoft's slowed down the pace of preview and GA releases and are now talking more about service enhancements. So typically we're seeing a lot more announcements about existing services rather than entire new services lighting up or new features lighting up. And that kind of timeline of getting previews out and into people's hands is starting earlier in the product cycle as well. So there are private previews that generally go on before you guys get to see this up in the Azure portal, but it's definitely worth going and having a play with some of those services because you can still affect how they actually get delivered, either when they go GA or post-GA as well. Microsoft's certainly very open to feedback on services that are in preview. Speaking of which, this month actually quite a lot of stuff happened. Build happened in March. Microsoft held, I think, back a few announcements for Build. The key ones, I've only talked here about some of the key ones. I haven't gone into everything in detail. If you want to find out more, the Azure announcements site has a lot of stuff where the teams will actually go and post quite detailed entries. About 18 months ago, it probably would have been Scott Guthrie doing that. He's kind of stepped back from that. I guess he's focused more on building the overall capability of the business. So the individual teams are now responsible for announcing those things. For this month, since we last got together, Azure SQL Database announced that they're supporting temporal tables in preview. So if you've ever worked with temp tables in SQL Server, Similar concept, not exactly the same, slightly different behavior to temp tables, but they're now a supported feature in Azure SQL database. And JSON support. I must admit, when I looked at JSON support, I think, are we looking at XML support all over again, and embedded XPath statements in the middle of SQL statements, which was never fun if you had to deal with it. It doesn't look like they've quite gone down that path, although there are some special functions that are available in Azure SQL database to cope with JSON data types. To be honest, it's just text. It should probably be treated as text, but they're there if you are interested in going and having a look at them. Azure Functions, this is an interesting one. Who's heard of AWS Lambda? One person in the room. You should leave now. No, I'm just joking. So AWS announced Lambda, I think, probably about a year, just over a bit over a year ago. And it's kind of one of those things where you look at it and you go, I'm not really sure that I see how that fits into the way I do software delivery today, but I think it has a lot of potential in future. So AWS talks a lot about this thing called serverless architectures, which is just, I guess, their way of avoiding having to say platform as a service, and making it sound like they invented the concept of serverless architectures. But Lambda allows you to have effectively API endpoints that you can call that will invoke some function somewhere inside of AWS and do something for you, or in fact do other things for you. They don't have to be inside of AWS. Microsoft took a look at that and they saw some value in that programming model. And their answer to AWS Lambda is Azure Functions, which is an event-based programming model. It's very interesting. Azure Functions has gone through a rapid life cycle from initial, should we be doing this, to here it is, and it's now available for you to use. So there's obviously some value seen in this space. Personally, I haven't worked very much with it. I played a bit with Lambda. Be interesting to see where that goes. Anyone had a look at Lambda in detail, functional event-based programming? No? No? Who's here for the IT pro session? Doesn't do development work? Yeah, probably most people. So tonight's an IT pro session, so that's fine. Azure Storage, I'd probably put those in the wrong order. Everybody goes, when can I encrypt stuff at rest in Azure Storage? Well, the good news is that you can. The way you do that, though, is through using an appropriate SDK. So the actual storage container itself doesn't actually understand encryption. It's just that you can read and write encrypted data to and from the actual platform itself. In the same way that you can encrypt data in S3, but you've got to do it before you read it in and read it out, because you own the process of doing the encryption and decryption. The other one that's good for us is import-export service is finally coming to Australia. In typical North American fashion, they said it'll launch in Australia in summer 2016, which I assume means it'll launch in Australia in winter 2016, because not the whole world runs on North American seasons. That's fine. And that's a good one, particularly if you're doing stuff in Office 365 where you might be using PST import service, where you can send PST files to Microsoft to import. That service is kind of there at the moment, but it's not really officially supported. This will see that be an officially supported service in a local data center, so you can create 8 terabyte drives and ship them to Microsoft, and they'll import them into storage accounts for you. Azure Automation, been around for a while. They've added a new preview feature that allows you to trigger automation events off of VM alerts. So traditionally, you could have still done this using runbooks, but now you've actually got the ability to do on an alert to do something smart like reboot a VM or something of that nature. So if you're maybe moving a workload to Azure that, how should we phrase it, is probably less than robust. If you've got some alerting mechanism that tells you when the VM is non-responsive or is having high CPU cycles, you can use Azure Automation to trigger a reboot of that VM automatically for you if the actual underlying Azure Fabric doesn't do that for you in the first place. And then the last one. So this came out last week, Azure Media Service Analytics. So Azure Media Service is Azure's streaming media video service, where you can upload source media files, video files, and then do on-the-fly transcoding and delivery to devices depending on their capabilities. There's been a lot of work going on behind the scenes in this team. And this is an interesting one. Media Services Analytics doesn't sound all that interesting, but when you actually look closely at it, it is quite a lot of information and capability baked into it. So they do facial recognition in video. They can do expression recognition in video. So not only can they see your face, they can figure out whether you're happy or sad or angry and all those sorts of things, I'm sure with a degree of accuracy. They'll do OCR, so they can actually read text out of video streams and do on-the-fly optical character recognition. And it's not just talking about subtitles that you might have in the video, it's actually talking about text in the video stream itself. So as you might imagine, that's not an easy problem to solve. And then there was automatic content moderation. So you can set some parameters around how much flesh tone you maybe want to see in the videos that get uploaded into your user-generated content stream. And what the media services analytics engine will do is it'll go, oh, hang on, there's probably something here that shouldn't be published, and it will flag it for you so you can actually go away and take a look at it, which, as you might imagine, for the likes of Facebook and Twitter and those sorts of guys where they get a lot of user-generated content uploaded, the ability to remove manual content moderation, or at least improve the degree of automated content moderation, would be very beneficial to those guys. So that's an interesting space if you're doing any sort of media stuff. I've talked to a few people that are doing that, and I think it's going to be something we'll see a lot more of in Australia in future. So that's in preview. Generally available. So these are things that have previously been in preview, so you've been able to use them without an SLA, and they're now available to you to use with a backed SLA. Azure Automation desired state configuration, so you can use desired state configuration to manage infrastructure as a service, VMs typically, to ensure that they're adhering to a desired state that you actually say, I want this machine to have these features enabled when it's booted up, which is great if you want to create a very large farm of machines from vanilla images and then apply a desired state to them. So this server's been about for a while, but it's now generally available, which means that there's an SLA attached to it. Azure SQL Database and Elastic Transactions. So the Elastic query capabilities of Azure SQL Database are delivered through an external tier that you call a software interface that you call that sits across your globally disparate Azure SQL Database instances. As part of that, typically you want some form of transaction capability where you can say, I'm going to write it to 5 instances that might be in Australia, Japan, India, and North America and Europe. And when all 5 of those have written, I want a transaction to basically go, it's done. Or if I fail to write to one of those instances, to roll back my transaction. So that's no easy thing to solve, but that service is now something that is generally available for your use. Azure Container Service. So this only happened yesterday. So that's Docker in Azure. It's not Windows containers yet, but it is coming. And they're backing, Microsoft's joined the Data Center OS conglomerate, so DCOS, and they've got the ability in here to support Docker Swarm and some of the DCOS stuff as well. So there's no mesosphere stuff in here at the moment. Microsoft doesn't see that it's mature enough at the moment, but if you're running Docker containers and you need somewhere cloud-based to do it, you can do that in Azure now if you want to. Document database, which is the JSON-based document database Microsoft's had out for a while, now has support for what are known as global databases. So it's effectively geo-replication of document database. And then finally, VM scale sets. So if you're using IaaS, infrastructure as a service, to host virtual machines, VM scale sets are now a thing that are generally available. I don't know if they dealt with your query before they went GA or not, but right, okay, yeah. So VM scale sets, again, are not something that are particularly new, but they have some features that are very similar to existing capabilities in something like AWS, which has the same sorts of concepts. Announcements. So this was a big one we had after the last session. So we had a cross-application development session based on Xamarin at our last user group. So I think the Xamarin announcement had happened just before that, but it was unclear what that actually meant if you were doing development in that space. Since then, Microsoft has announced that Xamarin's now available to Microsoft Developer Network MSDN subscribers as part of Visual Studio 2015 Update 2. So if you go and download all that goodness, you get all the Xamarin cross-mobile application development capabilities out of the box, which is really cool. So I know we've been using that since it happened. Azure Diagnostics and Audit Logs improvements, so just really allowing you to start redirecting a lot of service logs out into the ops logs capability inside of Azure. So That's probably moving more into the space that something like CloudTrail would have in AWS, where you effectively have one log sync where you send all of the information in your environment to one place that you can go and look at it, rather than having lots of disparate endpoints. Some changes around document DB. So in typical Microsoft fashion, they've gone, well, we can add a premium tier into this because people are asking for better performance or bigger databases, so we're going to charge more money for it. So there has been some changes to the way they're charging for document DB. So if you need more performance or bigger DBs, it's an option as long as you've got bigger dollars. A couple of interesting marketplace additions. So the marketplace is kind of Microsoft's third-party add-on solutions that you can deploy into Azure. Things like SendGrid have been in there for a very long period of time, but it continues to grow. So the two big ones from the last month was Splunk Enterprise, which is good if you want to do a lot of log aggregation and analysis, or you've already got Splunk in your business today and you want to maybe stand up an additional node in your Splunk environment. And also Tableau Server. So that's an interesting one, because Tableau is kind of the main target for Power BI from Microsoft. So you'd be wondering, why are they supporting one of their competitors in this space? Well, Microsoft doesn't care, because as long as it's running in their cloud, they're making some money from the consumption. So, you know, in that case, it doesn't matter who's deploying it. And the reality is if I'm going to buy Tableau Server and set it up and run it on an IaaS VM, end of the day, Microsoft's not going to know that, right? They want Azure to be an open cloud, so why not make it a marketplace offering so people can come in and push a couple of buttons and have a Tableau server environment configured if they want. Azure Stack, which is the kind of the generation 2 Azure data center, Azure in your data center offering. There's been some refreshes to that technical preview offering if you want to go and have a look at that. So that's hinging very much on the release of Server 2016. Which I think is still burbling along. I think they're up to release candidate 2 on that at the moment. I'm not sure if you guys are across that. Yeah, it's release candidate 2 or CTP.
To release TP5.
TP5, okay, cool, good. So I'm very out of touch. Thank you, that's all right. And then some Visual Studio tooling updates. So that came out of Build, which is Microsoft's big developer conference, including a Azure SDK update to version 2.9. So I've talked a lot. Anyone got any questions about what I've talked about? Anybody want more beer, more coffee, more pizza? Anybody want coffee? That's the next user group. So the next user group is going to be a breakfast. Not going to do it in the evening. We thought we'd try something a bit different. So I'd encourage you to go and have a look at the May Meetup and see if you can come along to that. It's going to be a good session. We've got Jason, who's here with us this evening, coming along to talk about his organization's journey from AWS to Azure and where some of the sharp edges are along the way. So it'd be good if you want real world learnings on that sort of move. All right, well, it's May 19 at 8:30 a.m. All right. So bring along a coffee. We'll have some nibbles and stuff out if you guys want to have a late breakfast, but you'll need to bring your own coffee. Unfortunately, we don't have a fridge that provides coffee, so unless you want to drink beer at that time of the morning, in which case you probably don't want to be at a user group at 8:30 in the morning. All right, so we're just going to do a little bit of technical cover to get Stephane set up, ready to go. So if you guys want to grab some more pizza and another beer out of the fridge while we're doing that, and we'll get started once we've got everything set up. Right, so you're unmuted, so...
All right, let's take it away. Yep. Zen.
Alright, so people can get to watch your presenter view. That's fine.
That'd be fine.
Yeah. Okay. Cool.
I'm happy to. Is there might be a way to actually replicate that here? I don't know about PowerPoint and how you would do that, but
so we can probably do.
there you go. That works. Sorry.
It's all right.
Hmm. Yep.
Okay. Good. Off you go.
All right. Okay, so who in the room has seen or heard of Azure Site Recovery? Well, we got two, and the boys. What about VMware? A lot of VMware users. I'm guessing the majority. That's always the case. That's why we kind of focus on the VMware side of things for Azure Site Recovery when it comes down to demos and talks. So that's what we're going to do today. Really a short PowerPoint presentation because I want to get stuck in the demo fairly fast. I know we don't want dead by PowerPoint, so we'll do it fast. But we'll see what disaster are, what most people do as a disaster strategy today, leading into what most challenges are in terms of disaster and disaster recovery, and then how Azure Site Recovery can help you with that. And then, of course, a demo. So surprisingly, a lot of people, when asked, what do you think a disaster is? What causes disaster? A lot of people think flooding, fire, earthquake, so all the natural events that occur where your entire data center just goes offline. But a disaster is really more than that. In the majority of the cases, disasters come from hardware failures. You might have your SAN go offline, for example, from of course your earthquakes, but also viruses. A lot of people get infected these days. You can never be protected enough. But the bottom two is probably the most common, which is human error. And with that, of course, the on-purpose errors. People get pissed off with the company and start to destroy things. So when we ask most companies, what are you doing today in case of disaster? They immediately think, well, we don't really need that because, well, let's face it, the chance of an earthquake in Sydney is so minimal that we don't need it. Wrong, because really it's all about all that list, not just the actual environmental problems that you might face. So in terms of strategies, these are the most common things that we see today in the markets in terms of DR. And the first one is the most common one. We just don't do it at all. Disaster recovery, what's that kind of question? So it's really bad, of course, but we've seen that because disaster recovery is a very expensive and a very hard exercise, a lot of small, medium, and even larger enterprise just let go on it and go, it's not worth spending the time, because again, they go back on the causes of disaster, which is probably more, it's not going to happen to us. The next thing is really using backup as a disaster recovery methods, which is not a disaster recovery method. A lot of companies rely on backup to disk to tape and then ship those tape off sites, And they all say, well, in case of a disaster, in case of hardware failure, it's no problem. We'll rebuild the server, get the tapes out, and just restore. It's not a disaster recovery method. This is your backup. This is not your disaster recovery. There's a big difference there. Other scenarios, these two, comes with a lot of expenses, but people do in larger enterprise do that. They have multiple sites, and they are to use those two sites as active-active or active-passive. In some cases, with really large enterprise, we'll see that, where they literally have a disaster recovery site and they just replicate between the two, usually at the SUN layer. What are the challenges with all that? I mean, the list is long, but what you really look at is really how hard it is to implement a disaster recovery plan. And this is not really the technology, because the technology is there, but more from an expense side of things and from a procedural side of things. So a lot of time and effort goes into trying to get that business continuity in place, which include disaster recovery. You also then look at, well, if you're going to do an active-passive site, for example, then there is all the expenses of your secondary sites. You need double the data because all your data has to be shipped off to the secondary site. Next thing, it's also when you start looking into disaster recovery, disaster procedures, people write them up, they create them, they've got their replication going on onto the secondary sites, and then they just leave it alone. And 5, 6 years down the track, a disaster happened, and that process has never been tested. So here's another thing that people look at in terms of expense for disaster recovery. It's all the testing procedures, making sure that these things work on the day there is actually a disaster, so that, well, you remove the stress from the IT department. So there's more, but this is, you get the picture. People think it's just too expensive. Where Azure Site Recovery comes into play, it's really trying to simplify and make disaster recovery affordable for people. So yes, of course, you still need all the processes in place. So you still need a lot of time spent on realizing what are your workloads you want to protect, what needs to be backup first, backup and running first. But once you get to the nitty-gritty of implementing the tool and actually implementing your recovery, Azure Site Recovery becomes a much simplified and much cheaper tool to actually do it. A few of the things it can do are listed there, which is you're not only talking about Microsoft technologies now, you're also talking about VMware. And because it does physical server, you're now looking at other clouds. Because if you can protect the physical server, nothing prevents you to do exactly the same for a virtual machine that sits in somebody else's data center, i.e. AWS or even any other data centers, really. And last but not least, when it comes down to simplifying the process, Azure Site Recovery comes with the power of Azure Automation. And Azure Automation allows you, in addition to Azure Site Recovery, to come to a point where your IT department, when you do declare a disaster, clicks a button. And that's it. That's all they have to do. And then just watch the progress bar anxiously. Is it going to work? But this is really, to me, the most important component of Azure Site Recovery. Because, well, let's face it, replicating data from one side to another, or from one side to the cloud, it's not that complex today. As long as you have a bit of money, you can do it. But really simplifying that recovery process when disasters strike is what, to me, is really important, and what Azure Site Recovery does really well across multiple platforms. So there's a few flavors of Azure Site Recovery. The first one is really on-premises to on-premises. So yes, you can use Azure Site Recovery if you do have a dual data center, and you still want to use that dual data center as your site recovery site. In that case, Azure Site Recovery really becomes your automation tool and becomes your management platform to manage that process of replication and to manage that process of, we're going to flick over now because we have a disaster. Again, you can do this on either Windows technology, Microsoft technologies, or any other. And when I say any other, of course, VMware is centric here, but also any physical machine that you have. So even if you're running a VM on a Zen server, you can still install the agent inside of that VM, and you can still use Azure Site Recovery to do that. The next flavor, which we're going to focus today on the demonstration, will be on-premises to Azure, to the cloud. And again, you can do this across multiple platforms in the same principle as what you do with on-premises to on-premises. You can do from Windows technologies or from VMware. And the dual here is more to say you can add the system center layer, as in VMM really, to simplify the management even further, because Azure Site Recovery will hook up with your VMM on-premises to actually simplify all the networking side of things. So really powerful, and of course very good because VMware. I think Simon touched on that very briefly earlier, but in regards to using Azure Site Recovery to VMware, with VMware, when Azure Site Recovery comes as a 30-day free trial. So we'll see later down the track how you can potentially use that as a conversion mechanism from your VMware environment to either the cloud or to the cloud Azure, and then back to your Hyper-V on-premises potentially. ASR architectures, and again, a focus here on really the on-premise. In a nutshell, this is what it looks like. So Windows technologies, VMware. In terms of Windows, Microsoft technologies, it's simplified because, of course, they hook up much better with their own technology than they do with the competition, let's face it. Whereby all you have to do really is implement an agent on your hypervisors. Of course, you can still do that on your physical server, but that's another discussion, another architecture. Install the agent on your hypervisor. This will start grabbing all the changes that happen on all your VMs that you've selected for discovery and ship them out to your recovery vault in Azure. And we'll see how that looks like in the Azure console. From there, you can then automate a failover from your on-premises to Azure. VMware and physical server, slightly more complex, although still fairly simple. The agent is not installed at the hypervisor layer, but installed inside of the virtual machine. Right? So same as a physical server would be, inside of the VM you have an agent. That agent will talk to a process server which is installed on site. The process server will take care of collecting all the changes that happen inside of the VMs, encrypt them, compress them, and ship them over to your site recovery as well. So aside from the fact that you end up with more agents and a process server on site, it's pretty much the same. And you'll see in the console in Azure, it's the same console. It's just a different way of grabbing the data and exporting it. Another thing that the process server does, which is quite important, is it does a conversion from VMDK to VHD on the fly. And so when your data lands in Azure, it is in the format of Hyper-V. It is a VHD. So this is where the conversion mechanism could come into play, whereby if you want to convert your VMware farm into an Hyper-V farm in Azure, ASR becomes a really interesting tool because it comes for 30-day free as well. So you could just use it, switch it off, and transfer whatever workload you want, even from Hyper-V, to be honest, but from VMware to an Hyper-V format inside of Azure. From there, you can then potentially just download all those VHDs back on site, and you have a converted environment to Hyper-V. Food for thought. Another interesting component that, aside from automation, is the networking side of things. And I've put this as just as an example because, well, networking can become really complex around disaster recovery and how you handle the network on your recovery side. As an example here, I took just a front-end web server and a back-end SQL server. Now, let's say that your front-end is using a internet, just a DNS entry to go out. Azure Traffic Manager can handle those DNS queries and automatically redirect your DNS query to a different site based on a failure of the primary site. Not only can it do that, it can also do load balancing. But in this specific case of Azure Site Recovery, you would set up Traffic Manager to handle all the traffic, all the DNS queries to be sent off to your primary site. And in case the primary site becomes unavailable, it will automatically redirect all your DNS query to a secondary site, which can be Azure or your second data center. So in this case, you then not only automate the shipment of all your data and you bring up your environment on your secondary site, but you also automate your user queries and how your user access your data. Because at the end of the day, there's no point of bringing up all your servers in your secondary data center or in Azure if no one can access them, really. So that's, I mean, Azure Traffic Manager can really be a session by itself because it's a beautiful tool within Azure, but it's just to give you an idea of, in combination with other Azure technology, what kind of automation and what kind of simple failover you can end up with Azure Site Recovery. Right. Questions so far?
Presumably, is it just asynchronous? Is it just an asynchronous replication?
Yes, it is. So you can do all the way down to 5 minutes. Every 5 minutes, everything will be shipped out, depending on the workload, of course. But you can do 15 minutes or more or less. Right.
You do like consistency groups as well?
Yes, absolutely. Yeah. So I'll go a bit more in depth on what the thing can technically do through the demo. I just wanted to go through the marketing slide first,
Right.
and, get us on the way. All right. So this is Azure. Can everybody see? Or should I increase maybe a little bit more? Oh, not too much. How about that? That's a bit better. Okay. All right. So in the purpose, this demo really focuses on VMware because it's the most complex to set up compared to Hyper-V, because Hyper-V integrates a little bit better. So in this case, I've created a vault, the role I, but we created a vault. A vault is before I start this, and please remember what I'm doing because I'm going to start the process of a failover now. A failover takes anything between 15 and 30 minutes. So I just want to launch the demo failover now so that we can actually see the end result and we don't run out of time. But we'll come back to exactly what I'm doing now, which is just failing over. Is that the right thing? Yep, it is failover. Note the shut down the on-premises. I'll show you that in a second. Okay, so just waiting for the job to start, and then we'll be on our way. Azure Site Recovery is not a fast technology, right? Let's face it, in case of a disaster, you're going to be really happy if your entire data center, for example, is back up and running within 2 hours. So it's not, oh, I want to fail it over, bang, it's there. It's really a process, and the more complex the environment becomes, the more VMs you're failing over, the more automation you introduce, the longer the process becomes, of course. Let me just check that. Yep, it's in progress. Great. Okay, so Azure Site Recovery. The first thing you do is, in the same way as you do for backup, you create a vault. You create an ASR vault inside of Azure. The vault will contain all the appropriate data and connection that goes back to your on-premises service, either your secondary or back to Azure. So within that vault, you then go and set up all your servers, processor if you need on site, in this case you do. You set up your protection groups, you set up your recovery plan. It's basically encompassing entire Azure Site Recovery. Once you have the vault, the first thing you will see after you create the vaults is a nice little wizard. These wizards allow you to select what kind of ASR you're going to implement. So on-premises VMM side to Azure, on-premises to on-premises, VMware physical server to Azure, etc., etc. So in our case here, we've selected this one, on-premises with VMware to Azure. You may note that if I change this, the actual wizard down the bottom changes as well. So it's really a small guide through on a step-by-step basis on how to set up ASR. So you can see there's a lot of work being done to simplify the entire process here. So the first thing Azure tells you to do is download the components for the on-premises, which is the process server. So this will grab an MSI installer that you just installed on the Windows 2012 R2 server, a virtual machine as part of your VMware environment, right? So that will install the binary necessary for that process server to run. The next thing is to go and grab a registration key. Now, all your data in your vault are encrypted, of course. So that registration key allows your agent to talk in a secure manner to the vault, so that the data being transferred across either the internet or, in some cases, express routes is done in a secure manner. Then they tell you to go read the manual, and then we can potentially add the vCenter servers. So if you have vCenter, Azure can communicate with vCenter to determine what VMs are running. Where are they? When you want to select your VM, it'll go and interrogate vCenter and authenticate against vCenter to grab all the administration rights to access all those VMs. When you're done with that, you just go create a protection group. Protection group will go through what it is, but it's effectively a collection of VMs that have the same type of replication timing, the same time of consistency checks, things like that. And then you add those virtual machines, physical or virtual, to your protection group. Once you're done with that final step, you're done for setting up ASR. At that point, all those machines that you've added, all the protection group that you created, the replication will start, and you'll know you'll have a replication of your data inside of Azure. Of course, the work is not done, because once you've got that, well, really you have to create your disaster recovery plan. This is really with all the work outside of IT, outside of a computer comes, and where you have to really sit down and think, okay, if I have a failure, what do I need to bring up? Do I need to bring up my domain controllers first? Of course. Do I need to do my SQL server next? Do I need to do my Exchange server? What's going to come up next? What's going to come up in parallel? These are all the decisions that you need to do, and from there, you can then create a recovery plan. And we'll see in a second how that looks like. From your recovery plan, you can then, what I just did in the back end, so it's running while we talk, launch a failure, launch a failover. Failover come in a few different flavors. You can do a test failover, which means you're gonna effectively bring up all those virtual machines in Azure without touching your production, in their own bubble, making sure that all the servers that come up, that all your services are started on the Exchange server, on the SQL server, make sure people can potentially connect to it and do what they do on a daily basis from a terminal server, for example. So the testing of your disaster recovery plan becomes easy, because again, it's a button that you click, and then you tell people, go to that public IP address and connect to the server and work, see what happens. So Microsoft, again, is trying to simplify that process so that there is less time consumed in the testing and the implementing of the disaster recovery process. Protection groups. As I said earlier, the protection groups are really a grouping of your virtual machines depending on the type of virtual machine and type of protection you want to enable for those virtual machines. So in the example of this specific group that I created for the demo tonight, you can see here that you can configure the group after you create it. So the group will determine what's the source and target, of course. In this case, because it's a VMware on-premises to Azure Vault, we have a source which is your on-premises process server, the PS-Prem, and your target is Microsoft Azure. Now, the settings that you can configure for each of the protection group are down below this. The first one I'll focus on is the RPO. Your recovery point objective, which is you want to determine for those group of virtual machine, how much data can I afford to lose? Can I afford to lose 2 minutes? Can I afford to lose a day? Right? And say, okay, well, for that specific group of virtual machine, I'm going to do a synchronization for 240 minutes, 2 hours, because I can afford to lose 2 hours. It's no problem. If it's a SQL database, well, let's do 2 minutes. So at that point, every 2 minutes, the agent is going to fire off all the changes from that specific, so from those specific VM, and shoot them over to Azure to keep into a blob storage. Okay. The retention of recovery points is also an important point because, pun intended, because let's say you have a virus infection and you're doing a 2-minute replication. If you take an hour to realize, oh, there is a virus, I need to declare a disaster. Well, that 2 minutes, during that 2 minutes, the virus is getting replicated back to your secondary site, to Azure. So keeping your recovery point to a certain extent becomes really important because you can select within that period which of the recovery point do you want to recover onto. So you can go back to, I don't know what the maximum is, but let's check it out, 72 hours. So you can say within those 2 minutes, I want to keep all those for 72 hours. It's going to use more blob storage, of course, but you can do it. Application consistent snapshots. That's also a very important one because really the synchronization of your data is at a block level. All the changes that are made, right? You talk about a SQL server, for example. SQL could get in trouble if it's unaware that it's been backed up. So you could end up with an inconsistent database on the other side if you're only using that technology. This is where the consistent snapshot comes into play, where every single, in this case, 60 minutes, the agent is going to talk to the VSS provider. The VSS provider is going to ensure that the application is in a consistent state inside of the virtual machine and then being replicated out. Right? In the case of VMware, the agent is inside the VM, so it'll just talk straight to the VSS. But in the case of Hyper-V, it'll just talk through the two VSS. And finally, to answer your question, multi-VM consistency, you can ensure that through those application consistency snapshots, all the VMs within that group will have the same consistency through the snapshots. So they all are in a consistent state, but also at the same time. So that if two SQL databases, for example, are part of a mirror, you are sure that they are consistent with each other before they get replicated back to Azure, and they can be brought back up.
This was a technology Microsoft acquired.
Yes, correct. Yeah, in the case of VMware, yes, it was InMage. In the case of Hyper-V, it's all based on Hyper-V replica in the back end. Once you've got your protection group defined, quick note, you can see protection groups, VMM clouds. So you are going to use exactly the same interface if you're doing an Hyper-V to Azure, or Hyper-V to Hyper-V, or a VMware to VMware. You're all coming into that same console. You just go to separate parts of the console to actually set those up. So in this case, there is no VMM because I'm doing a VMware demo, but this is where you would come to actually register your VMM server, and then have all your VMs being brought back through VMM into Azure. The servers, again, you can see here VMM or configuration or Hyper-V side if you don't have VMM. In this case, configuration server relates to VMware. You can see I've set up a vCenter alongside with a process server which is on premises. The process server doing all the conversion, the encryption on the fly. Right? Once you're done with that and you've got your protected items and it's all nicely replicated, I'll show you again just to show you. So ASR demo SQL 01 is the virtual machine I'm currently failing over. And again, I'll show you the process for this. You can see where the active location is and the status. The status will show if you haven't started replication, a failover, replicate it with a green tick. If it's not replicated properly, by drilling into the virtual machine, you will be able to see what the problem is and where the problem is. So you can see here down the bottom that there's only one disk to this. It's 30 gigabytes. 20 seconds ago, there was a data upload, and the replication status is okay. All right. Same principle here. It makes sure that the process server is accessible from the VM itself through the agent. And if not, it'll alert you that the agent cannot communicate with the process server anymore. Once you set all this up, the next thing to do is to create a recovery plan. Recovery plans are, again, the process that the system is going to use to fail over virtual machines, to fail over a group of virtual machines. Within a process, and I'll show you here the one we're using tonight, you can define a lot of things. The first thing you define is groups. Your groups are how a virtual machine will fail over. So the entire process is sequential through groups, but runs in parallel within groups. So for example, if you have, say, two SQL server in a mirror and you have a front-end web server, you might want to create two groups, one for your SQL server, the second one for your web servers. Put your two SQL server into group 1 and your web server into group 2. Launch the recovery process. It's going to start with group 1, not touching group 2, and recover, fail over your two SQL server first. Once group 1 is completely done and those virtual machines are up and running, only then will it go to group 2 and start the same process for group 2, but again in parallel. So if you have 10 servers in one group, it's going to start failing over those 10 servers at the same time for that group. Another very interesting feature here is you can have some automation scripts using Windows automation. In this case, I wrote a very small script that goes ahead and open the RDP port on the virtual machine I'm failing over. That script comes directly, so for example, here, that script comes directly from the automation side of things. So if I select some runbooks, you can see I've got a few runbooks there in the Azure automation. You just go and write your script, for example, opening a port or changing an IP address or whatever you want to do with your automation. And you can run that script after or before every group. So you know that that's going to be done sequentially. For example, you might want to, if you fail over domain controller, after domain controller comes up, you might want to re-register change all the IP addresses inside of DNS for that domain controller. That can be done on the script right afterwards. Reboot the domain controller afterwards, things like that. Yeah. You can also introduce manual actions. I think we all realize that not everything can be automated. You will still have some things that you need to do manually. In order to interrupt the process, the scripting sequential process, you can introduce a manual action. Now, the manual action is, for example, here after group 1, you can introduce a manual action. The script will then stop right there at the end of where that manual action is and wait for you to come back to the console and say, yes, I've done the manual action. And in here, you can just put up a description. This is my description. So that when the person actually do hit the failover button, this will appear and go, oh, hang on, I'm stopping here. You need to do this, 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 this. And when you're done, come back and click the OK button, and I'll carry on with the process. When you create a recovery group service, the name that you name your recovery plan of will translate into a cloud services that is being created in Azure for you. Okay, so if you have 2 SQL Server and 2 web servers, and you put them as part of the same recovery plan, they will land in the same cloud service for you. Now, one of the restrictions, and this is another one out, but does anyone know how many VMs you can do as part of one cloud service? 50. That's the maximum. So just be careful if you do your recovery plan, if you end up with 200 or 300 VMs that you have to protect, never to exceed that magic number of 50, because your recovery plan will fail because of that reason, because it will all try to put it down to the same. So ASR Cloud Service 01 is the recovery plan I just launched at the start of the demo. Now, once you created your recovery plan, and this is where we go into it, you can select the recovery plan and either do a test failover or a failover. So in this case, I went ahead and selected number 1. So I'll select number 2 to show you what comes up. If you do an unplanned failover, you can then decide from where to where, on premises to Azure, or you can change the direction and go back from Azure to on premises to revert the process. And here the interesting bit is you can select which recovery point you want to fail over with. The latest one, the latest application consistent recovery point, or the latest crash consistent. Now, the crash consistent is the same principle as you say when you boot up your Windows and you've got that nice little window to say Windows didn't shut down properly. Right? There is one missing out of this one, which is, maybe there isn't one on the other one, which is to be able to go back to another point in time, but unfortunately I don't have that. You can also say, based on the amount of recovery points you're keeping, you can have a list of all the recovery points with the dates and time and go and select a specific recovery point to recover. Once you've done that and you click OK, the system will launch a job, which we did several minutes ago now. And we can see here, this is the job being done. So in this case, I failed over that SQL Server that I have on premises. Now, the SQL Server is, I mean, for the purpose of this demo, we're talking a very, very simple single server. It's literally just a SQL Server that is running on premises. Part of a work group, so no domain control or anything else, because it would just take too much time to demonstrate. Now, I don't know, I mentioned earlier when I launched the actual script to go and shut down the on-premises machine. So just to show you, that's the vSphere client, web client. It was running at the time. I'm just going to refresh it now, and that should be now the SQL Server is powered off. So the Azure went to talk to the agent and said, I'm doing a failover, please shut down, and shut down the virtual machine on the actual premises for you. Of course, in case of a large disaster, you will need to do that because the VM is probably gone by now. But anyway, so a couple of things that the system will do for you is described here. Okay, so the first thing it did, because I asked it to, is go and shut down. And you can see that it goes into a sequence through those groups. In this case, there's only one, of going in and recreate. So the first thing it does is the planned failover. So it goes in and creates that cloud service for you, goes and grab all the data from blob storage and create the virtual machine for you inside of Azure. This is quite an important point because you haven't paid for any resources to the day. All you paid for is to protect that instance, which is a fixed price. But the resources that are now going to be created are only being paid for when you actually declare a disaster and failover. So in this case, I think I selected a A4 for that machine. So now I'm going to start to pay for the storage and for the resources being used by this specific virtual machine. Prior to this, I wasn't paying for that. I was only paying by protected instance. Important point. Once this is done, the system will go ahead and so the cloud services create the virtual machine and start the virtual machine up. Once the virtual machine is up and running, I've said, go ahead and please automate and open the RDP port so I can actually connect to the virtual machine for the purpose of this demo. And then finalizing the recovery plan is just cleaning up the storage on the back end where ASR puts all the bits and pieces. So if we now look in the cloud services, we'll see we've got a cloud services that is named after my recovery plan. Now, a little trick, a little tip. Cloud services are named, have a unique name across Azure. So if you use a cloud services that is already being used by somebody else, you'll end up with a nasty GUI ID at the back end of that. Right? So that's how our Azure Site Recovery deals with the fact that it can't create that cloud service. For automation purpose, that could create some problems. So what I always do before I create a recovery plan is go and create a cloud services with the name I want to use and see if it's in use or not. And during the testing of your recovery plans, you can check that the name is still available for you. We now have an instance. We will in a second anyway, if I refresh. Within that cloud services, a VM was created, which is my ASR demo SQL 01. If there was multiple VMs, they will all be under that same cloud services. So if you want different cloud services, you need to create different recovery plans for you. A quick side note, you can also not use a recovery plan and just fail over one machine manually from your protection group. You can just literally hit failover, please. And it will only fail over that specific virtual machine. There it is. It's not appearing in my cloud services yet, but it will in a second. But now my ASR demo SQL virtual machine is there. And you can see here in the dashboards, some reason the interface is not refreshing on the other side, but you can see here that it's part of the ASR Cloud Services 01 cloud service. And it's done already. So in the backend, while I was saying that, the script for automation has gone and opened port 3389 on 33891 publicly, so that I can now access and go click on the virtual machine and go connect. And in just a second, we'll have a SQL server that was running on premises from VMware, which is now running in the cloud. So this will support, by default, any loads, any workloads that is compatible with, that's an interesting point, and I'll explain why this comes up. This will support any load that is compatible with VSS snapshots. So SQL, Exchange, Oracle these days, it's working now. used to be a bit dodgy, but it works now, and many, many more. So there is a ever-growing list of compatible applications, application aware, that is on the Azure website. Now, why did it come up as a dirty shutdown? Because I selected the last replication. I didn't select the application consistent snapshot, right? So of course Windows is going to go, oh, I shut down dirty. That's, you know. So my SQL database could be damaged in this case. But it's just for demonstration purposes. And that concludes the demo. Any questions?
If you actually went into testing in that environment over there, can you actually change right into that environment and revert back? Tested it, say you might revert.
This is where your test failover comes into play, right? So if you do a test failover, your production is not touched. So you can literally go and bring it up, and from there, inside of your recovery services, come on, that's it. You can go and delete a replica by simply disabling the protection or stopping the managing the virtual machines. Now, there's a big difference between the two. The first one will just stop the replica, but will keep all the data in Azure, so that when you re-enable your synchronization, you don't have to upload all your data again. It will just carry on with the Delta again, while stopping the managing the virtual machine will delete everything in regards to the virtual machine. So if you test your recovery plan with a test failover, you realize it's not working, not a problem. You just stop the replication, disable the protection, and then re-enable your protection, and you're back to square one again in pretty much no time, because only the Delta, since you tested it, is going to get transferred across. Right?
Anyone else got any questions for Stephane?
Yeah. Yeah. Yep. Correct. So a vault cannot span across multiple regions. No. So once you create your vault, you have to create in a specific data center. So in this case, probably here in Sydney, but you can create a vault in the US and use those two separate vaults to protect different machines, but you cannot span your vault across multiple regions. No. So once you decide where the protection goes to, that's where it goes, because your agent will always go and register itself through the process server to a specific vault by use of that public key.
But the walls behind.
Yes. So in every single data that's been transferred lands on blob storage. So it's also, you got 3 copies geo-replicated. So your data is effectively safe. The problem is that I think if I understand the previous question well, is if that region goes down, so does your vault. And if the vault goes down, the agent can't talk anymore to the vault and cannot replicate anymore. Right? So yes, you will get a redundancy between the 2 regions. So say, for example, you decide to create a vault in Sydney, and Sydney goes down. My assumption is in the back end, Microsoft will fail over to Melbourne, and your vault will come up in Melbourne. But this is outside of your control, right? At the point where Sydney goes down, your vault becomes inaccessible, and so does your replication. But I'm guessing again that Microsoft will kick into gear to go, well, let's use the geo-replication copies and bring up the vault somewhere else. That's my understanding. But there is no SLA against that, unfortunately.
What's happening in terms of IP addressing?
Thank you. I completely forgot about that bit. So for every virtual machine that you protect, you can configure what size it's going to be in Azure and what network it should connect to. So by default, the system will present you. So here, what's the name of the virtual machine in Azure, and what kind of virtual machine resources I want to use for that specific virtual machine when it lands in Azure. By default, the system will present you the same number of network connection as the number of network cards that were defined on the on-premises. So in this case, I've got one network card, which is identified here. And I can then decide to go and connect to a specific Azure network. I created just a VNet for those for that testing. The VNet comes back with X amount of subnets, and in this case, I can go 10.90.1.200, for example. If I want to define the IP address, if I do not, it's just going to grab the first available IP address on the subnet that you put up, as for any other VM that you do when you deploy a VM inside of Azure. Right? So from here, it becomes really a lot of preparation work in terms of your networking on the Azure side, and go try and either replicate what you have on premises, pre-replicate that with your virtual networks inside of Azure prior to create your vaults and your replica. So that once you start creating those and adding more and more virtual machine, all those networks are already pre-created, and you know, based on security and IP addressing, where you want to put every VM on what subnet you want to put them. Yeah.
When we talk about the VMware application, can provide the vCenter and can provide vCenter inside.
That's correct, yes.
But you can't add a single box. Either you center or.
No, you can do both. So you can have multiple process server on site. So once the connectivity between a vCenter will happen through one of the process server. But for example, if you have your VMware environment and you decide, well, I need, I've got 10 VMs, I need a process server there, I'm going to hook it up through vCenter because it's easier to manage. That vCenter connection will go through that process server. If next to that you have 10 physical machines, all you have to do is install another process server and hook up those physical machines through that second process server back to your same vault. And they can both land on the same vault, no problems there, except that one will be outside of vCenter management, the other one will be within. Maybe an interesting one is once you hook up into vCenter, this is what you can see. So when you add a new virtual machine to your protection group, it will present you with one or multiple vCenter that you can drop down and select. And it will tell you through vCenter what machines are accessible. Note that you can't set up protection for a virtual machine that is powered off, because the agent is inside the virtual machine, of course. So it needs to talk initially to the agent inside. And also note that you need that, what they call the mobility service, which is the agent, to be installed on the virtual machine to have a successful setup. So in this case, for example, I've got a couple more virtual machines here. Yes, I have a look at the required bandwidth. This tick box here is new. People complain that they've set up ASR, they go next, and suddenly the entire WAN is completely flat out for the next 2 days because they got a 10 megabit connection and they decide to do synchronization and just took all the bandwidth. So this is really a disclaimer to go, we're going to impact your storage and your bandwidth, right?
How long does it take to replicate the 100 gig instance, let's say over a gig length, but there is no bandwidth constraint?
If you have a gigabit, that means you're transferring at around 100 and 100. No, it's public. So the maximum you can transfer with Azure Public, which is ASR, is 200 megabits. So even if you have a gigabit link, you will always get throttle on the Azure side with 200 meg. So your 200 meg is around the 18 megabyte a second. So that's what you'll get at that point. That's per vault. per vault. So if you create a vault in Sydney Southeast, you create another vault in, Australia Southeast, another vault in Sydney, transferring to those two vaults will be in parallel at 200 and 200, right? Even with express routes, you still have that limit of 200 meg, unless you go premium. Then with premium, you get more bandwidth allocation to you. But by default, it's 200 meg maximum.
Can you pre-seed vaults?
Not at this stage, I don't believe so. That's a good question. I might shoot that over to Microsoft, because I think they were talking about it in the same way as backup. But at this point, I don't think you can. Yes, probably, yeah. So once you've gone next, you can then select what process server you want to use for this one, and what storage accounts you want what blob you want to use, basically, for all the replicated data to be used. So in terms of licensing, in terms of costings, what you'll see is that you'll end up with a fixed cost per virtual machine up to a certain amount of storage, and I believe that's 500 gig. So for any protected instance up to 500 gig, you pay a certain price. I think it's $20, $29 per virtual machine, I believe. And then thereafter, you double the instances. So for every 500 gig block of storage for a protected instance, if you have 600 gig, well, you're effectively paying for a terabyte. But you don't pay for the resources, right? Even if you select a G4 as the destination virtual machine in Azure, you're not going to pay for that CPU and RAM unless you actually do a failover. And you only pay for what you use. So as soon as you fail back, or if it's a test failover, you'll only pay for the time that those virtual machines are up and running.
So the deltas, you say they're stored in the vault?
They're stored in blob storage, right? So your vault is really all the settings that relates to Azure Site Recovery are in one vault, but along with the storage that is associated with that vault. So any data that comes in will be associated with the vault, will be encrypted with the vault key, but put onto blob storage in the backend.
So if you've got a say like a fail back scenario, you need storage backend or something in order to select a snapshot.
No, because the failback works really, it's completely the opposite process. So you will go from your blob storage back to your on-premises hard disk or SAN or whatever it is that you've been using. The account here is the administration account for your vCenter. So this is where you go, well, this is the account I want you to use, and has all the right permission to go ahead and communicate with that VM. Once you've done that, you hit the OK button. We'll see here in just a second, you'll have a new virtual machine popping in and starting to synchronize. And now everybody at work is going, the 40 meg is used. Who's doing what? But this is why Microsoft had to add that little disclaimer, because of that. Unless you throttle your link yourself, you will find that Azure and the agent will just dump as much as possible data over as much as possible bandwidth it can, right? Just to get to that point of being synchronized.
You have the processor system already.
Yes, correct. Yes. So the process server, there's nothing much to show really. So this is the process server there. The actual binaries in the backends, they're all invisible. So it's literally just a service that is running on the VM. Try and see if I can connect to that. Wow, that's tiny. I know, hang on, let me put my glasses on because I think I made a typo in administrator. No, no, it's fine. I think it's more from memory, really, than reading it, to be honest. So the process server is really the sorry about that. It's just a demo environment. The process server is really a leftover from image, right? So I don't know if any one of you have ever used image, whatever you pronounce it, Azure. It's really a process whereby you have a set of binaries that runs on that process server through a certain port. So if we look at the configuration, once you've installed the binaries, the system will automatically launch this wizard here, which is allowing you to connect, allowing you to set up your vSphere account. Right? So this is the list that we can see in Azure, because it will communicate that back out. So you can, in this case, go and add and remove vSphere accounts potentially for administration, right? It will go through the Vault registration. So when in that wizard we saw at the very beginning, the dashboard, you download that Vault key. This is where you point the Vault key and what type of connection you use to the internet. As in, I want to go through proxy or not. Localization, if you want to do it anywhere else than English. And then the interesting component here would be the port configuration, whereby the process server, what port is it going to talk to Azure with, right? So the only port you need to open, outgoing, incoming, no, outgoing, both, no, just outgoing, is 443. That's it, right? And then from there, the Azure connectivity is established. Once that's done, and you close this, this is all you have to do on the process server, except giving the process server enough resources to cope with all the changes and get all the changes. The resources are mainly CPU and storage. CPU because of all the encryption work, of course, compression as well, because it sends it over compressed. And storage because, well, you need to be able to capture all the deltas, and depending on the size of your environment, that can creep up. That's right. Yep. So when that happens, and it can realistically happen in Azure, you will see that your RPO thresholds is in failure. So you'll get a big, massive exclamation mark going, "I can't cope with the 2 minutes RPO you're setting me up for, because the bandwidth is not large enough and I'm running behind." So you'll get an alert for that, and then from the alert, you'll then have to decide, do I upgrade my bandwidth, or do I have more realistic RPOs? But the system will keep going. So, and this is where the storage on the process server can grow a little bit out of control, because all your recovery point will be stored on there until such time that it can be shipped off to Azure. Look, realistically, if you start talking about, I'd say any environment today would be at the very least 10 virtual machines, because you need a couple of domain controllers, a file server, a SharePoint server. You can potentially do that for that type of small environment with at least 10 or 20 megabit, I'd say, roughly. I would introduce some QoS in there to go limit the bandwidth for that specific job. During the day, for example, if you have the devices to do that. But you can definitely do it on a 10 or 20, but not with a 1 meg. Oh, you can. Ah, there you go. So you can actually limit that today. Just changes too fast. Can't keep up.
You could manage the onboarding of your environments as well. So rather than just
Like, that's right. That's right. That's right. And this is also what the beginning is, that the setting up of the tool is really 30% of the work. The 70% of everything else is thinking about what do you want to protect, how do you want to protect it, what's your RPOs, do you have enough bandwidth to do that, and the calculation that comes around that. But 10 meg shouldn't be a problem for small environments. And again, I hate to say it, but it really does depend, because if you have a very small environment, but your 5 virtual machines are 1 domain controller and 4 SQL server, and the SQL server pumping out changes like there is no tomorrow, your 10 meg is never going to be able to follow, unless you do a 2 or 3 hours RPO, a 2-hour RPO, which is the maximum, right? So you really have to calculate that at the time when you know what the environment produces. We, from a backup standpoint, which can correlate with this, we always go with a rule of thumb that any server, and of course it's plus minus, so it's an average, creates about 3% of delta every day. So you look at the domain controller, it'll be more like 1%, while SQL Server might be more like 5, 6, 7%, depending on the load. But on a rough guesstimate, you'd say 3, maybe 4% a day. That's what you're looking at for delta. So if you look at a terabyte, that's 40 gig that you have to transfer every day. Over a 10 meg, over a 24-hour period, that's absolutely possible. You can do it. It's gonna use your link quite a bit, but yeah. No, just compression at this point. Compression is fairly good because I think they use the same as DPM, which you get around the 30-40% compression. So your 30 gig or 40 gig then really becomes 30 gig or 25 gig, depending on the data again, but around 30-40% compression. Microsoft is talking about dedupe for backup at this point. Once it gets there for backup, it's going to get there for the rest, I reckon. But it could be quite further down the track. Yeah.
Just clarification, so I didn't understand properly. When you failed over, is the actual process completely reversed? Replicate back to production?
Correct. Yeah.
But your blobs are then still.
So you will then use the data. So once you fail over, your blob storage is effectively transferred and creates virtual machine based on that blob storage. So now your virtual machines become literally just a workload. Once you do the failover back, you basically say, well, this is my primary site now with my virtual machine in the same way as you did originally with the agent inside there. And this is my secondary site, which is your on-premises. Right. No, it doesn't work that way. So once you the failback process is not a disaster recovery protection. Right. So that's right. That's right. So once you failed over, you effectively have declared a disaster. Your environment is brought back up inside of Azure. If you then want to implement another disaster recovery because, well, you're going to leave it there, that's not a failback. That's a complete different process where you can potentially, I haven't tested that actually, but you could potentially do a ASR Azure to Azure. I don't think that it exists today. I don't think you can do that. No, but they're talking about it. Yeah. So you can't really look at it once you failed over as another disaster recovery process. The failback is really going, okay, I failed over. I'm now running as a disaster. I'm going to fix my site. Once the site is done, all my data, I'm going to transfer it back across. Resynchro. That's right. Yeah. It's alive. Whatever change has been made then in Azure, because user have carried on working, will then be transferred back onto your on-premises. No, you have to resynchronize. You have to resynchronize the entire data, yes, the entire data set. Because the principle is this, right? Once it goes across, it's not a disaster recovery process. It's really a failback. And if you look at why would you transfer across? Well, say you have a hardware failure. You're going to have to replace all those disks. so it's going to be empty anyway. Say you have a virus infection, you don't want to take the risk to reuse the data. You have a malicious somebody that goes and corrupt your data. Again, you don't want to reuse that data and use the delta on top of that. So in most cases, you will want to resynchronize all your data anyway.
So
right?
does that mean then going back and everything's out of action for a while? Or
No.
it takes to go back, or
No, you. It's a replication.
the failover and then it just changes afterwards.
That's right. So you still initiate a data transfer while your original, while your failed over in Azure is up and running. So your user can still use that while the synchro is happening. And then at some point you say failover. And then everything gets killed there and everything comes back up on premises. In the same way as when we said failover there, I did tick the box to say, please shut down the on-premises. And then it's just a matter of bringing up those workloads in the other side. You'll see that the VMs on the other side, when you do a failback, Azure will talk through vCenter to go and create all the virtual machines on your VMware, on your ESXi. So you'll end up with all your virtual machines, with all the disks attached to the virtual machines, and the synchronization will happen straight through vCenter inside of the VMDK. Again, a reconversion back on the fly through your process server. And once that's all done and you go failover, it just brings up those virtual machines. Right? You configure that at the time. So it's the same principle as when you set up a failover and you say, I want this IP address, that IP address. When you configure the failback, if the environment is gone, you will have to say, well, this virtual machine used to be on this IP address. You got to configure that. No, that's right. That's exactly right. So the process here is really, I think part of the thought process from Microsoft, and I kind of hate that marketing slide, but it does make sense to some extent, is they go, once you failed over and it's running in Azure, why would you fail back? That's what they're trying to push, right? No, because really, when you look at it from non-environmental perspective, and you look at more the realistic scenarios, which is my SharePoint server just went blue screen, it's gone, because all my disk underlying went. You declare a disaster for that specific machine, you fail it over to Azure, you no longer have the need to go, I want to restore from backup, or I need somewhere else in another data center to bring that machine up. You can bring it up in Azure. Once it's up there and running, then you have a decision to make to go, do I synchronize back and bring it back up in my data center, or do I leave it there?
Because there's no Azure.
No, that's true. So in Azure, the way then to protect it in Azure is different, because in Azure, what you really need to do is start to run on separate sets, VM sets, because, well, there is no SLA for a single VM in Azure. But on sets, they do that, and they do geo-replication as well from a disk standpoint. So you end up with a higher running rate based on availability sets and geo-replication. From there, you can then also instigate Azure Backup, which technically allow you to, and I'm going back to contradicting myself, never use backup as a disaster recovery method, but technically you could then use that to bring back up your virtual machine in a different region if you wanted to. That's right, absolutely. It's not perfect yet, but I think they're getting there. You can always do from on-premises to on-premises as well, and use all the recovery plan automation that comes with Azure to actually do all the work effectively in the back end. Price is different at that point. I think it's a third or half the price if you decide to do on-premises to on-premises for the automation component. Yep.
I got a question to the network traffic. If you fail over a single machine,
Mhm.
that machine will live in Azure then.
Mhm.
How is the communication done? Is there a tunnel or
Well, that's up to you to determine to architect the solution properly, right? So you can either establish a permanent connection with Azure through a VPN or through ExpressRoute. And when the machine is getting failed over, have a new IP address and have a permanent domain controller, for example, in that new subnet. When the machine comes up, just declares its new IP address to the domain controller, DNS changes start to replicate, and your VM is accessible through that VPN tunnel or ExpressRoute. This is just an example on how you could potentially do it. Instead of reusing and literally grabbing your entire environment with all your subnets and dropping them in Azure, you could potentially extend your data center through VPN or through ExpressRoute inside of Azure. Have a read-only permanent domain controller there that you know is used by your on-premises as a secondary or tertiary DNS server. And when it comes up on the other side, it will go and declare itself anyway. Right, so you'll end up with a situation where your IP address for your server will change, but eventually through the use of domain replication, you will have that new IP address coming through to the so your client will be able to access that SharePoint server X amount of time after it's been failed over.
Yeah, the problem is more on the firewall side.
Again, you need to architect the networking layer. It's probably a big component of disaster recovery, and that's across the board. Outside of ASR, disaster recovery become a bit of a I'm going to say a nightmare, but it's a bit mind-boggling when you have a lot of networking involved, especially with zoned firewalls, etc., to actually say, let's move that all, or let's just grab a little bit of that and put that there. So again, it's that 17% of brainstorming and to go, let's analyze all the scenarios and decide what do we want to declare a disaster for, right? And draw that line and say, if a server fail, I'm not going to do a disaster because it's just a too complex solution. I'll just recover from backup and take the time it takes, right? So it's really a discussion that needs to happen within IT, but not only within IT, but at the business level. Because if you do not involve the business management, you cannot have a successful disaster recovery plan, because they need to tell you what do they need, right? But you've got the technology in the back end that might say, well, you can't do that, right? So it's a two-way conversation and a decision that needs to be made at the two-layer.
We might wrap up the session
Yep.
there. I'm sure Stephane will hang around if you want to ask him
Absolutely.
any additional questions about the session from this evening. So big round of applause for Stephane.
Oh, thank you. No, don't. You're going to make me blush.
As I said, May 20th will be our next one. We're doing it as a breakfast. It'll be another IT Pro focus session on moving stuff from AWS to Azure, so it should be another good one. Thanks a lot for coming. Feel free to hang around. There's still a little bit of cold pizza left and still plenty of beer in the fridge if you want to grab another one. Thanks a lot for coming, guys. Appreciate it.
Thanks, guys.
Thank you.